Look at some of the costs of electrifying roadways. That is over a large number of roads having an electric wire over each lane, allowing cars and trucks to take power from that line to operate. So what would the costs be? Let's say you want to have a 10 by 10 mile square, so that each vehicle would be within 5 miles of a road in a straight line, but should be within 10 or 15 miles certainly by driving distance to a road which would have the power lines overhead. There are about 3 million square miles in the United States. To have a 10 by 10 mile grid is 100 miles, and you need 2 roadways on each square when you put a large number of squares together, so that's 20 miles, or 1 mile of road for each 5 square miles of land area. That's 600,000 miles of roadway that would be needed. There are about 400,000 miles of highways in the United States. The highways are not evenly distributed. So let's say you need another 400,000 miles of county roads. Let's say each highway has 5 lanes on average. That's a total of 2 million lane miles. Let's say that the county roads have an average of 4 lanes. That's 1.6 million lane miles, a total of 3.6 million lane miles. In addition, in urbanized areas, you want to have additional power lines. So for each square mile of urban area, it might be desirable to have 2 roads going north and south, 2 roads going east-west. There's over 300 million people in the United States. If you assume 10,000 people per urban area, that's about 30,000 square miles. 4 roads is 120,000 square miles, and at least 3 lanes average per road. That comes to about 400,000. So that's a total of 3.6 plus 400,000, or about 4 million lane miles. The overhead electric line costs $200,000 per lane mile. That'll be $800 billion. If it costs $300,000 per lane mile, that'll be $1.2 trillion. At financing cost of 8%, even $1.2 trillion would be about $100 billion per year. There are about 180 billion gallons of fuel used every year in the United States. They produce about 9 kilowatt hours each of useful power. Electricity costs vary. One of the common numbers is 10 cents per kilowatt hour for nuclear, 8 cents per kilowatt hour for wind. If you assume at least 9 cents per kilowatt hour, the 9 kilowatt hours of useful power can be reduced through regenerative braking. This is what a hybrid vehicle uses to improve its mileage. So the useful amount of power is actually something below 9 kilowatt hours that are needed to replace the gasoline. On the other hand, there are line losses, transmission losses, electric motor losses, and battery storage losses. If one assumes, let's say, it averages out to 10 kilowatt hours necessary to replace a gallon of gasoline, at 9 cents, that's 90 cents. Times 180 billion gallons of fuel is $160 billion. $100 billion for finance costs, plus $160 billion for electricity, is $260 billion. A barrel of petroleum, if it costs $90 a barrel, is about $2.20 per gallon. In addition, there are refining, transportation, and distribution costs. So without taxes, it would cost about $2.70 a gallon or so. At $100 per barrel, that would be $2.50 per gallon, give or take, and about $3 per gallon total cost. Times 180 billion, that comes out to a total cost of between roughly $480 billion to $540 billion. $260 billion necessary for the power lines and electricity has to be augmented by the fact that some people are going to waste the electricity and steal some of it, and you have to have maintenance and repairs for vandalism, theft, and weather. But if those costs even come up to another $140 billion, $400 billion, the savings would be on the order of $150 to $200 billion. That would mean that if you were to stretch electric lines everywhere and give the electricity away for free, there would be $150 billion to $200 billion more for other uses in the U.S. economy, meaning that things like the XL pipeline are stupid and unnecessary. The device on the top of the car that would make contact with the power line is called a pantograph. It is awkward, it is stupid, and it's pretty goofy looking. The other problem is the stability of the car. You're adding weight above the roof line of the car, which would make it more easy, ready to tip over. And if you get a crosswind, that will also make the car lean. But $150 billion to $200 billion is a big chunk of the U.S. economy. It's over 1%, in fact. And that would have a significant economic impact, which means you could replace fossil fuel, you could replace the XL pipeline, and actually save some money. The other question is the batteries. Now, because it only has to drive about 10 miles, the battery can be made much smaller, much lighter, and much less expensive, but it is another cost that has to be considered.